So there's not much left to go over. Just these are like really specific commands. We're gonna go over while loops. We're gonna go over block copies, basically just extracting a block of text. We're gonna look over default sites. We're gonna look over begin log and end log. So there's a specific purpose for those. And we're going to look at the script command. So there's not much left, and these are really specific.
A while loop, is that like a logic term?
It actually just stays on the same line, and it'll keep processing lines of the same format until something no longer matches. So it's right here. So it's normally used if you have multiple alarms coming in. Well, like if there's a big block of text that comes in, and that big block of text, like right in the middle, has multiple alarms for each line. You could actually process through each line as an alarm, as long as it has the same format, and it'll generate an alarm for each of those. But it'll keep something from the very first line, and you'll grab something new from each line. Another.
That's if your alarm comes in clustered like that.
Yeah.
Correct?
And then there's maybe some specific data at the very top that only shows up once. You can use it that way. I've seen it also used where there's a bitmap, and you have your alarms in a bitmap. So you have a set of dots and ones. And for some reason your alarm data comes in as either a dot or a 1, and it's in a specific position. We've used while loops to go through that whole array and figure out which alarm should be set and which one should be cleared. One example I can think of is on that Guardian when you do like an SNP get for one of the displays. It'll give you back a bitmap. It's pretty much like an ASCII string, which has a dot if it's clear and 1 if it's set. The first item being 0.1, and the next item being 0.2. There's like 32 either dots or 1s on that same line. So we use a while loop to kind of go through each single one. We increment a counter to determine what point that should be setting. So for parsing bitmaps, we use that. So there is an example here how to use that, but it usually starts with a /w followed by the condition. That would pretty much tell you what to look for so you would stay in the loop. And then this D command would be the do part of your while loop. So while you're in the while loop, this D section here tells you what commands to start with. So once it gets to the end of the line, if it still thinks it's in the while loop, it'll go back to wherever the /D is. /E is the end of the loop. So once it gets to the /E, it'll check this /W, and it'll check the condition again to determine whether it needs to do the whole loop again. And it's usually like the next line, or it could be like the next character. So here is actually an example section here where they have a /W. Let's go ahead and zoom in here. So there's a /W, and then the condition, which is match on point. Let me zoom in a little more. Oops. So that's right here. So we're looking for point. As long as point exists, we're going to go ahead and repeat everything in between this, the /D at the /E, which would be C3 is to clear key slot 3, C4 is to clear key slot 4, F1 moves the cursor one position, it'll put whatever the position is at, key slot 3, it'll move forward one more and put it key slot 4. And it'll keep doing that as long as we see point. And the input is actually up here. So here we've got Fresno and put into key slot 1. We put a colon to key slot 2. Now we have all these points here. 0.2, 0.5, and 0.4. Each of them with different states. We're looping through each of these lines. As long as point exists, we're going to clear key slot 3 and key slot 4. We're going to move forward 1, so we're going to go after point. It's going to go 2. I put in the key slot 3. It'll grab fail, put in the key slot 4. Then it'll go to the next line. As long as point still matches, it'll clear 3 and 4, and then it'll grab 5 and fail again. When it gets to this E, it's going to evaluate. It's going to evaluate the alarm. So down here actually shows the action keys that's being generated. So it actually generates 3 action keys with a single rule. Fresno, since we had put it in here before we went to the while loop, and we never cleared it inside the while loop, would stay there the whole time. So here we're actually explicitly clearing key slots 3 and 4. So this was that example where the points come in a bunch, like they come in clustered together. And then here at the end you have end report, which no longer matches point, so we're done with our while loop. And here's another example of a while loop with text associated with it. And there's an example text here. There's example rules out here to match this text up here. So what it's doing is just looking for status, and it's looking for report and looking for cell, which shows up at the first line. Second line looks for alarm and looking for status. And this third line is just looking for this pipe symbol. So it's only looking for 3 lines. Rules here are pretty much grabbing number 47 as a site. So here we're looking for cell. So we're looking for cell, we're moving forward 1, and we're putting it into key slot 1 and 10. Then the second line, we're just putting a colon into key slots 2 and 4. Pretty much the same as we were doing with that example. And this third line here is doing a while loop. And it's doing a while as long as we don't match on end. Like as long as we don't see end. So we're looking for end report. So it's going to grab alarms, it's going to grab status. Looks like we're using key slots 3 and 9. So we're making sure those are clear before we do anything. We're putting everything into key slot 3. So the hard separator to key slot 3. That would basically grab alarm. And then it grabs the rest, puts it in key slot 9. Yeah, so they have the pipe symbol defined as a hard separator. So KH3 for alarm would just grab alarm colon. Moves forward 1 hard separator, it'll grab status. And it'll put it into key slot 9. Then I'll try to evaluate that. And then it'll keep looping until it finds an end. So the next line will have door into key slot 3 and open into key slot 9. So it looks like key slot 9 is the state or the status. Key slot 3 is the alarm. So here again we have different alarm types and different statuses, all for the same site. So we're just looping through each line and getting the status. So next we have an example. So we're going to create a rule to handle, there's a bunch of text there in the workbook. Basically this big chunk of data here. So each line here contains an alarm point. We're going to use a while loop to parse through each each of those messages and create an action string. So what we're going to use to start the line is RTRV. So we're going to match on RTRV, which was at the very beginning, which is actually a response to retrieve all alarm. So this whole thing is a response from a device whenever we send retrieve alarm all. And it gives us this big chunk of data. If you have alarms that are standing in TMON, and for some reason the ASCII message to clear it didn't come through or had been missed, this command here will only return what's currently standing. You're basically going to do begin log and whatever address this is supposed to affect. Every rule that runs in between begin log and end log, from whenever those get called, is going to mark every alarm that didn't get reset. It'll go ahead and clear those. So when we see begin log, we're going to mark every alarm point inside adder to be cleared. All the rules that run between begin log and end log is going to set an alarm point. So basically, back to our TL1 example, all those messages are going to set an alarm. Once we get to the end log, everything that hasn't been set to say an alarm is going to get cleared. So that's a way of refreshing all your standing alarms. If for some reason they go out of sync or the TML was taken out of monitor mode and it wasn't monitoring when certain ASCII messages came through, our while loop would be /w, and we're going to match on a double quote. When we don't see the double quote anymore, that means we're done with our loop.
Okay.
So as long as we see the double quote, we're going to keep processing that while loop.
Got it. Okay.
Yeah, the text up here did say it was a negative match for double quote. Yeah, I guess the verbiage here is it's asking when we know the loop is complete. We're just making sure we don't see the quote. But to stay in the while loop, we would look for a quote. Okay, so the next rule we were going to go over was the while line loop. So this is the one that stays on the same line. The while loop will actually move on to the next line as soon as it hits the /e. So for the while line loop, it's just going to stay on the same line. It's going to process multiple items on the same line, and it's going to generate a key off of that. It's pretty much formatted the same way as a while loop, except there's an L there. So the /WL is the start of the while loop. And the conditions are pretty much in the loop. Just looking for any match in the loop. And it exits at /EL. Then it'll process whatever's after that when it no longer matches.
So what is the C0 at the end of the example?
That actually clears all the key slots, but it looks like it only happens after we finish our loop. So at the very end of the line, we go in and clear our key slots. And it looks like they did that because inside this while loop, this /* forces a key and generates alarms based off of what's currently in there. As soon as we get out of that loop, it'll basically process the last alarm that we had just generated. So looks like they use C0 to clear their key so it doesn't create that last alarm twice. So this input here looks like it's just looking for overtemp, smoke, fire, it's like how long, and it's pretty much just looping in this line. The comma is a sauce separator. It's just grabbing one item, putting it into key slot 1. Then it's generating a key to create an alarm for overtemp. Moves forward 1. Goes back in the loop, puts smoke into key slot 1, and then it creates another alarm based off of that. Moves forward 1, restarts the loop, puts fire into key slot 1, it creates another alarm based off of that, and moves forward another one, and then it restarts the loop and puts this into key slot 1 and generates alarm based off of that. Then it moves forward one, which is the very end of the line. It'll go ahead and exit process after it's going to process what's after /el, which is to clear all the key slots. Oops. Just so it won't regenerate this last alarm that we had just created.
And so instead of getting a single alarm that says over temp, smoke, fire, halon,
they have four
you get
different
4 alarms.
Yeah, which would have 4 different action strings as well. In this case, let's say their action keys are just over temp, smoke, and fire. So there's no clears here, so it would just set the alarms, and there's nothing that could clear those unless you manually clear the alarms. You'd have to actually clear it on T1. So, and I have an example of that here, where we have generator run, door open, AC fail. And their commas separated. So we're matching on alarm report for site. It's a little small there. So we're matching on alarm report for site, and then we're matching on a dot for the next line. No, sorry, we're matching on a we're matching on a comma. So generator run, door open, and AC fail. There's a comma on the second line. The first line, we're looking for site, and we're grabbing what comes after site, which is Fresno. Actually, it's like Fresno COs, or we grab, and then we put ALM into key slot 9. That's actually right here. So we're forcing into alarm. Then our loop, we're just actually going through and grabbing these point descriptions, and we're creating action keys based off of those. But we've already grabbed Fresno from here, and we put ALM into key slot 9. So our action strings would have alarm in all of them. It would just basically put generator run into key slot 3, then it'll have door open in key slot 3, and it'll have AC fail in key slot 3. Okay, so the next one would be the ASCII block copy. So this one's pretty simple. As you're moving the cursor along our text, you can put a /B to put a cursor in the current position. And then you would just do like /forward1. Just keep moving your cursor. You can even move it to the very end of the line, or you can match on a certain keyword. And then you can do /KB, and then whatever key slot you want to put your text into. So it's going to grab whatever you had originally marked with B, all the way up to where you're currently at. So this example here puts a /B /forward3, so it's going to move forward 3 soft separators, and it'll put in the key slot 5. Yeah, so it looks like we do have an example where it looks like XML strings here. This third line here, where it has a description, has this big block of text inside. Could vary like how many fields are in there, but we see description at the very beginning and the very end. The rules here. So this third item here, it's matching on description. We're matching on the forward. We're matching on the greater than symbol. We're moving forward 1. We're putting our cursor. Actually, we're marking our cursor there, and then we're looking for the less than symbol, and we're actually moving back 2. So here what would happen is, I'm actually just looking at 3 here. So the third rule here is processing the description field. So we're looking for we're looking for this symbol here. We're moving forward 1, that would move to EOC, and then we're matching on this less than symbol slash, which maybe a little hard to see there, but that's what we're matching on here. And then we're doing F-2, which actually moves back 2 soft separators. So at this point, we're down here. We're going to move back 2 soft separators. We're going to go back to number 2. So it actually looks like we're skipping up. We're going to 2. And then we're putting everything in the key slot 3. So we put the marker on EOC. We moved basically all the way to the end. We looked for this less than symbol, and we moved back 2 soft separators, which would end up on 2. And we placed everything in between our marker and where we're currently at the key slot 3. So it grabs this big long string here, puts it into key slot 3, and that string is going to vary. The way this is formatted, that description could be anything. So looks like they were trying to make sure that the description was the same, but they couldn't use the last word, which was up and down, because those were different. This alarm status down here actually says open and close, so they could use that to determine the alarm status. So something like that, where you have something that could vary, but you just want to grab everything between certain tags. Most of the time you can get away with just KH to go very end of the line, but here we can use the last 2 items at the end of the line. Even if that's the case, I think you could still get away with doing not KH. You can do FH1, that'll move forward 1 hard separator, and then do F-2, that'll still get you that here. As long as you know there's a hard separator after here. So the next one will be the default site. So all this does is set the default site. In our example, we were using Fresno_DPS as our site. If for some reason that doesn't show up, or it's not in the message, or maybe it's optional, like maybe our message just has an asterisk and then there's nothing after it, we'd want to have a default site there, so it wouldn't go to unsorted. By default, everything goes to the unsorted address on Tmon, where everything will just start collecting. This default site, you could actually define a default site name, so in case slots 10 through 14 doesn't exist, you'll at least have something that makes more sense with what that alarm might be. This example down here is actually for the next one. This FWD, which will forward log text support, which will just forward to a craft session or to another job on Tmon. Usually it's a craft job or another ASCII interrogator. So it's used for debugging. And then we have begin log and end log, which we've kind of been going over as part of the other rules here. When you call begin log, you specify an address, and all it does is mark every alarm point in that address to be cleared. Then you run some rules in between begin log and end log. Anything that generates an alarm would set that alarm to stay in alarm. Then when you call end log, it'll clear whatever wasn't set. So we've kind of already gone over this with the while loops and with the while line. The script option here will allow you to call a script where you can send commands to the far end ASCII device. So if you see certain text coming in, maybe we had used this for like logging in, or if we see the word password, or maybe some sort of greeting that we know that it's a login prompt. We'll look for that and then we'll run a script, and that script will just, here we're just entering the username and then the password. This D option here will wait a certain amount of time. So here, this example, we were looking for this system restricted. Yeah, this system is restricted access system. Whenever we see that, we call the script here. And this script, all it does is wait. It says team unlock, carriage return, waits a few more seconds. It says team unlock 09, the carriage return, and then it sends this command here. So there's username, password, and then whatever command it needs to get started. So if there's any ASCII devices that needs input from TMON, this is what you would normally use. And if there's something you can key off of where you can trigger like anything to send to that device. We've seen a few where the ASCII device logs this out and I believe it tells us that it's an invalid command whenever TMON tries to send some other command to get like alarms or get the current status. Whenever we see that, we just call a script to log back into the system. That was basically all we have for ASCII.